Yesterday we started to break down the how in terms of measuring specific heat capacity, but what we're going to be focusing on today is more of a demonstration. So when we're talking about specific heat capacity, we're talking about the energy needed to either raise or lower the temperature of any set reaction. So for example, if we take hydrochloric acid and sodium hydroxide and put those two things together, alone they're pretty dangerous, but if we mix them and we get the correct solution, then we can make salt. Now we can actually feel a lot of heat associated with that reaction, and that's where knowing specific heat capacity for different substances comes in handy, and it's pretty important. So we're going to go ahead and take a quick look at a little demonstration here. So we have sand and we have water. Now in terms of the specific heat capacity of each, the water will have a very high specific heat capacity, whereas the sand will have a very low specific heat capacity. And a great example of that is like when you're on the beach. When you're stepping on the beach and you're kind of dancing on the sand because it's a super hot day, well, that's because the sand is absorbing heat much more quickly than the water is. So you can see that if I were to take this candle and hold it over this bucket, obviously, and I take my sand and I hold it here, it's the change in temperature is pretty quick. It didn't pop the way that I wanted it to, but you can see that, well, obviously. Now, if I take the water, normally we have a lot better stuff in class, so that would have been a much grander experience, but that's okay. Demonstration's all the same. So if I take the water and I hold the candle here like this, I actually don't even need the bucket. So think about like when you are cooking pasta or something, right? When you put the pot on the stove, it takes forever for that water to boil, right? Well, that's because water has such a high specific heat capacity that it takes a long time for the heat to change the temperature of that given amount of water. What you did yesterday was you showed how to know how much energy is needed to cause that reaction or see that kind of change. What we're going to be focusing on again today is the things that are associated with it. So when you look at today's follow-up assignment, I want you to keep those things in mind. Always think about sand and water on the beach because it's the best example that we can think of, right? The water is super, super cold, but the sand is super, super hot. And it's because they have such polar opposite specific heat capacities in terms of the amount of energy that they can either take in or release at any given moment. So there you go.